You see a triangle when three dots are arranged at its corners. You hear a melody even when individual notes are separated by silence. You group birds in flight into a flock, not a collection of individual birds. The brain does not passively record sensations. It actively organizes them into meaningful wholes. The Gestalt psychologists, Wertheimer, Kohler, and Kafka, argued that the whole is greater than the sum of its parts. Perception is not built up from individual sensations assembled piece by piece. It begins with organized wholes and fills in details. This insight fundamentally challenged the prevailing elementism of the early 20th century. The figure ground principle describes the automatic perceptual organization of visual scenes into a figure, the object of attention in the foreground, and the ground, the background against which it appears. Reversible figures like the Rubin vase demonstrate that figure and ground can spontaneously flip, revealing the active constructive nature of perception. The principle of proximity holds that elements spatially close together are automatically perceived as a unified group. Three widely separated dots appear as three individual elements. The same dots clustered together appear as a group. Proximity overrides color, shape, and other properties in determining perceptual grouping. The principle of similarity causes us to group elements that share visual features, color, shape, size, orientation, as belonging together. A grid of circles and squares is perceived as rows of each kind, not as a uniform matrix. Similarity guides grouping even when proximity would suggest otherwise. The principle of good continuity causes us to perceive interrupted lines as continuing smoothly. The principle of closure causes us to mentally complete incomplete figures. A circle with a gap is still perceived as a circle. Both reflect the brain's tendency to impose the simplest, most stable interpretation on ambiguous sensory input. Bottom-up processing begins with raw sensory data, the features of the stimulus itself, and builds upward toward perception and recognition. Feature detectors in the visual cortex respond to basic elements like edges, angles, and movement. These low-level features are combined into shapes, then objects, without prior expectations guiding the process. Top-down processing uses stored knowledge, expectations, and context to guide perception. You read misspelled words correctly because your knowledge of the language fills in the gap. You hear your name across a noisy room because your brain is primed to attend to it. Context shapes what we perceive as profoundly as the stimulus itself. Perceptual constancy allows us to perceive objects as stable despite constantly changing sensory input. Size constancy. A friend walking away does not appear to shrink. Color constancy. A white shirt looks white in sunlight and candlelight. Shape constancy. A door is perceived as rectangular whether open or closed. The brain corrects for context automatically.